Hey everyone, today we're going to go ahead and talk about sequences. In algebra there are two types of sequences, arithmetic and geometric. Arithmetic sequences have a common difference. So for example, the sequence below, it starts at 2 and then adds by 3 to get to the same number. So the difference between every number is 3. Geometric sequences have a common ratio. This one's a little different. This sequence starts at 1 and multiplies by 2 to get the next number. So here we have those two sequences written out, and we'll say that sequence A is the arithmetic sequence and B is the geometric sequence. They are asking us to write an explicit rule for each sequence, and we'll talk about what that means later. One more thing, along the top row you'll see this word term, and that refers to a number's place in the sequence. So the first term for A would be 2, and the first term for B would be 1, and so on and so forth. Since A is counting by threes, it is said to have a common difference. Therefore, it is arithmetic. Sequence B is multiplying by 2, therefore it is said to have a common ratio and is to be geometric. So let's get into writing these explicit rules for each sequence. Arithmetic sequences follow this formula. A is the name of the sequence. A sub 1 would refer to the first term of the sequence. D refers to the common difference, or what we're adding or subtracting by to get from one term to the next. N is our variable. Now, N stands for the term of the sequence. So if we're trying to find the first term, N would be 1. If we're trying to find the 26th term, N would be 26. It's always going to be our variable in our rule. So let's go ahead and write our function rule, A sub n, which refers to the nth term of the sequence A, equals 2, which is the first term, plus n minus 1, that's going to always be the same, times the common difference of, well, this function, the common difference was 3. That's what we're adding by each time. On to the geometric sequence. It follows a different rule, and we're just going to go ahead and call this function g, even though on the previous slide it had a letter b. So g sub 1 stands for the first term of the geometric sequence. R stands for the common ratio, or what are we multiplying by, or dividing by sometimes, from term to term. N is still our variable, and it stands for the term that we're trying to find. Let's write our rule, g sub n, which is the nth term of the geometric function, equals, in this case, the first term was 1, the common ratio was 2, we're multiplying by 2 each time, to the power of n minus 1. That's our rule. Okay, in part 2. Part 2 is they want us to find the 9th term for each sequence. So, what we'll do is we'll substitute the number 9 in for n. If you remember correctly, I said earlier that n is the term we're trying to find. So in this case, they want us to find the 9th term. We'll substitute in 9 for n. Arithmetic sequence. We substituted 9 in for n. So this reads, the 9th term of the arithmetic sequence is 9 take away 1 is 8. Bring everything else down. We're following order of operations. 8 times 3 is 24. And 24 plus 2 gives us 26. So the 9th term of that sequence is 26. If we were to keep going to 9 terms, we would eventually get to 26. Now let's do the geometric sequence. The 9th term of the geometric sequence equals, 1 times 2 to the power of 9 minus 1. Let's do that part first. 9 take away 1 is 8. And we will simply just do 2 to the power of 8, multiply it by 1. Well, really, 1 times anything is going to give us that number. So 2 to the power of 8 and 2 to the power of 8 gives us 256. So the 9th term of the geometric sequence is 256. One last thing, notice how the arithmetic sequence after 9 terms only got up to 26, whereas the geometric sequence got up to 256. One function, the arithmetic, rises in a linear way. The geometric function, in this one function b, rises exponentially. As always, if you found this video helpful, like, share, and subscribe, and we will see you next time.